Hey everyone, and welcome to Joys of Code. Today, we are pulling back the curtain on the secret life of a data packet. We're going to follow its incredible journey from your screen across the entire world and back again, all in literally the blink of an eye.
No, really, have you ever stopped to think about it? You click a button to send an email or maybe a message, and poof, it just shows up on someone else's screen. What kind of magic is happening in that split second? Well, spoiler alert, it's not magic. It's actually this amazing high-speed journey, and we're going to follow a piece of data from the very start to the very finish.
All right, let's dive right in. To really get this journey, we first have to understand what's actually, traveling. What even is data when you get right down to its most basic fundamental level?
So, at the very heart of every single photo, every email, everything on your computer, there's a language called binary, and it is ridiculously simple. It's made up of just two things, a 1 and a 0. That's it. Everything you see on a screen is just an unbelievably long string of these ones and zeros.
You know, the easiest way to picture this is with a simple light switch. If the switch is on, let's call that a 1. If it's off, that's a 0. Computers are basically just using billions of these microscopic on-off electrical switches to represent all the complex stuff we work with every day. It's a simple concept, but it is incredibly powerful.
So, we've got our data, this long string of ones and zeros. Now, for it to go anywhere, it needs an address. But here's where it gets interesting. To get anywhere on the internet, it doesn't just need one address. It actually needs two completely different kinds.
First up, you've got the IP address. You can think of this exactly like the mailing address for your house. It tells the massive global network of the internet which specific home or which office network to send the data to. Basically, it gets your data to the right neighborhood.
Okay, but once that data arrives in the right neighborhood, the right network, how does it find your specific laptop or your phone among all the other devices that might be there? That is the job of the MAC address. It's a permanent, unchangeable ID that's literally burned into your device's hardware. It's like your device's unique fingerprint.
And this is exactly why we need both of them. Let's stick with the mail analogy. The IP address is the postal address that gets the letter to the right house. But the MAC address? That's the name on the door that makes sure the letter gets to the right person inside that house. You absolutely need both for a successful delivery.
All right, so our data is all packed up. It's got both of its addresses. It is time to send this thing on its way. So let's take a look at the Digital Postal Service, the actual hardware that physically moves our information from point A to point B.
Now, on a local network, like in your office, you'll find things called hubs and switches. A hub is kind of like an old-school tannoy system. It just shouts the data out to every single person connected, whether they need it or not. It's noisy, inefficient, and not very secure. A switch, on the other hand, is like a smart teacher who knows exactly which student to hand a note to. It intelligently sends data only to its intended recipient, which makes the whole network way faster and more secure.
So if the switch is the local mail sorter inside one building, the router is the entire city's post office. It's the big gateway that connects your local network, your office, or your home to the massive, sprawling internet. Its main job is to look at that destination IP address and figure out the absolute fastest, most efficient path for your data to take out of millions of possibilities.
You know, as networks get bigger, they can get really chaotic and slow. And that's where something called subnetting comes in. Just imagine a huge school with one giant noisy hallway for everyone. It would be a mess. Subnetting is like building walls to create separate departments. You got the science wing, the arts wing, and so on. It divides a big network into smaller, more organized sections. And this makes everything faster, more secure, and just way easier to manage.
Now, for all these different pieces of hardware, made by thousands of different companies all over the world, to work together perfectly, they all have to follow the exact same set of rules. Think of it like a universal blueprint for how data gets packaged and sent every single time, without fail.
And that blueprint is called the TCP/IP model. It basically works like a little assembly line. First, at the application layer, your data is created. That's the email you just finished writing. Then the transport layer chops up that email into small, numbered pieces called packets. Next, the internet layer stamps each one of those packets with the destination IP address, the mailing address. And finally, the link layer adds that local MAC address, the recipient's name, creating a finished little package called a frame that's ready to hit the road.
So, we've seen the bits and the bytes. We've seen the addresses and the rules of the road. Let's zoom out a bit. How are all these pieces actually arranged? And maybe more importantly, why does any of this techie stuff matter to us in our jobs and our daily lives?
So the way all these devices are laid out is called the network topology. Honestly, just think of it as the floor plan or the map of the network. It just shows how everything is connected to everything else.
Now, there are a bunch of different layouts, like the old-school bus or the circular ring, but the one you almost certainly use every single day is the star topology. At home or in the office, all your devices, your laptop, your phone, your TV, they all connect to one central point, which is usually your Wi-Fi router. And it's so popular for one big reason. It's reliable. If one device's cable gets unplugged, everybody else on the network stays online.
So why do businesses pour so much money into building and maintaining these complex systems? Well, it all comes down to real-world value. Networks drive massive efficiency by letting whole teams share expensive resources, like a single high-end printer. They make collaboration possible through centralized data, so files can be easily shared and securely backed up. And, of course, they are the absolute backbone of all modern communication, from email to those video calls we're all on.
So there you have it. We followed the entire crazy journey, from a simple idea getting translated into ones and zeros, getting packaged up with addresses sent zipping through smart switches and powerful routers, all while following a super precise blueprint. We've literally built our entire modern digital world on these principles. So the big question that leaves us with is this: now that we know exactly how it's all built, how on earth do we keep it safe?